This lecture is going to cover the section of your textbook that introduces measures of central tendency. So when we're talking central tendency, we're basically talking or asking what can we describe about those middle or central characteristics of a group of numbers or scores or observations. So we're talking about the mean, the mode, and the median. I'm hoping that a lot of this will be review for you, but it may put it in a different light than you've ever looked at before. So let's take a simple example. I've given these students, there are 9 of them, I've given them some kind of measure, and these are their scores. So then I've got a frequency chart there for the scores also. So we're going to use this as an example. When we're talking about the mode, it's very simple. We're asking which score occurs the most often. Which observation is the most common? That's the mode. And in this case, 6 is the score that is earned the most. So the mode is simply 6. For the median, we're really asking which score represents the 50th percentile or halfway. So if you've got a few number of scores or observations, you can simply line them up from lowest to largest and then count off from the top and the bottom until you come to a middle point. In this case, if we arrange all the numbers from the highest down to the lowest and we go to the midway point, that's 6, which is the 50th percentile. The problem is that if you have a large number of observations or data points, or if you group them into class intervals, then you need to use a formula, which is given in your textbook. It's formula 3.3. Note that if I'm going to use this formula, I need the cumulative frequency and the cumulative percent that's accounted for at each of those intervals. This is looking familiar, isn't it? When I plug the correct numbers into my formula, I end up with a median score of 6.3, which is pretty well what we predicted using the simpler way, just going along by sight and taking the midpoint. So I've given you here on this screen the different colors to show where I got those numbers from. Once again, we're using the lower limit of the interval of interest. And remember that we're using the cumulative frequency from the interval below that again. This is really just a modification on the formula that you would use for the 50th percentile for a group of numbers. Now I'm going to talk to you a little bit about the mean and hopefully bring out some things about a mean that you've never thought about. The mean is simply the arithmetic average of scores. A mu, which is that first symbol there, means that you're talking or indicates that you're talking about the mean or the average of a population, all of the possible subjects that could be tested or scored. A bar X indicates the mean of the sample. So most often in inferential statistics, we're going to be using a bar X because remember, we're taking a sample of a population and then we're making inferences about the population from what we can find out. So I hope that you're making a note of some of these symbols in the sheet that I gave you where you can track the symbols used in inferential statistics. When we figure the mean, it's really easy, and you've been doing this since grade school. But look at the symbols here and take them apart so that it's familiar to you. The mean of a sample, that's the bar X, is equal to the sum of the scores, all the scores of X. That's what the I indicates. It means all of them that there could be in this sample. And then you divide that by N, which is the number of scores or observations. So in this case, when I add up all of the scores and then divide it by 9, I get a mean of 6.555555, which I'm going to round to 6.56. The properties of the mean are incredibly important in understanding statistical analysis. We will be coming back to this over and over again. We use the mean frequently. So the first property that's important to understand is about the deviations of the scores from the mean of that group of scores. Deviation simply means the difference. So how far does the score deviate from the mean? What is the difference between the score and the mean for the group? And often we replace the group scores with a mean. So we need to understand this, how far are each of those scores from the actual mean? When we add together the deviations from each score, so here, what I've done back here, I gave you the deviations. So a score of 6 is 0.56 below the mean. A score of 5, student B's score, is 1.56 below the mean. A score of 7 is 0.44 above the mean. Those are the deviations. When I add all of those together, if I sum all of those deviations, we end up with 0. In this case, if you get out your calculator and you add these all up, you're going to actually end up with 0.04. It's actually 0.03 something. And that's simply because, remember, I rounded up the mean in each case, but it is virtually 0. The second property relates to what we call the least squares. The sum of the squared deviations, or the differences from the mean, is a minimum. And that's really important, and we're going to be coming back to this over and over again in inferential statistics. The space between the scores and the mean is that when we square that space, that gap, that difference, that is always going to be a minimum, and we call that least squares, as your book mentions. At this point, I just want you to kind of understand this, and we'll come back to it. That minimum, that deviation from the mean, the squares of each of those is going to be smaller than the sum of any other deviation squared. So look at this chart and what we've done here. The deviation for student A from the mean is a negative 0.56. Going across to the right, when I square that difference, I end up with 0.31. So that's the squared deviation for student A. Let's look at student E with a score of 7. That student's deviation from the mean, the score was 0.44 above the mean. When I square that, the squared deviation is 0.19. Let's do one more. Let's look down here at student I. That student's score was 5. That means that student scored 1.56 points below the mean. And when I square that, the squared deviation is 2.43. So this column I've added, at the top of it, it says any student's score minus the mean squared. So that means the square of the deviation from the mean. If I add those all together, they come to 14.19. Now I'm just going to pick a random number in this group of scores. I'm going to say it's 7. You can use any number you want to if you want to try this yourself. But I'm now going to take student A's score, and what is its deviation from 7? Well, 6 is 1 point below 7. So student B with a score of 5 is 2 points deviation from 7, a negative 2. Let's do another one. Let's look down at student H. The deviation of 9 from 7 means that that student's deviation from 7 was a +2. Now look in the far right column. Look at what I've written at the top. 7, and you could have picked any number you want to and worked out the deviations. I just picked 7, and it doesn't matter what number you use. 7 minus any score, in other words, the deviation from 7 for any score, squared. Let's go back to student A. That student's score, the deviation from 7 is a -1. When I square that, the squared deviation from 7 is 1. Let's look at student C. Student scored 7. The deviation from 7 is 0, and so the square is 0, obviously. Let's jump down to student G. Student G scored 8. So the deviation from 7 is a +1. When I score that, it's 1. And that's how I got the numbers in this far right column. What's important to understand for the second property of means is that if I add up and get a sum of all those deviations from 7 squared, I end up with 16. No matter what number you use to deviate from, the sum of those squared deviations is always going to be larger than the sum of the squares of the deviations from the mean. So any number you use to deviate from in these green columns, that the 14.9 is going to be lower than that number. We're going to come back to this later. Be very careful that you remember what means are. Remember that they're averages and they're based on the number of people in the group or the number of observations or scores. If you try to average the means of two groups, you have to weight for the size of the groups to get the actual average. So if Mrs. Jones' class has 36 students in it, and the mean on a test is 36, and then we've got Mr. Martin's class, he's only got 25 students who took the test, but their average was 42. We want to know what the mean is for the whole grade level. We cannot just add 36 and 42 and divide it by 2, which would be 39. The average is not 39. We had 36 students. The size of the group with the mean of 36 was much larger than the size of the group with the mean of 42. So we have to account for the size of the group. And this is what we call weighting. It must be weighted for the different weights of n, or the different sizes of the groups. So this formula comes out of your textbook. Let's read it together from the left to the right. So if I want bar x, if I want the mean of the entire grade level, I have to take, that's equal to, I have to take the 36 students from Ms. Jones' class and multiply that by 36, their mean. Then I add together, I'm going to weight the mean of 42. I'm going to weight it by 25 times 42. Then I'm going to divide that by the total number of students in the entire grade, which is 36 plus 25. In other words, 61 students. When I do that, the actual average or mean for the entire grade level is 38.46. It is not the same as 39.00. So be very careful about that and work through that section in your textbook and make sure you understand that. So we've been through central tendency. Remember that what we're doing is we're asking, what can we describe about the middle or central characteristics? The mode is really easy, and the median isn't tough to understand, and the mean is easy to understand, but you need to start getting your head wrapped around the two properties of the mean and what you're doing when you're weighting for group size, when you need to weight them because of different group sizes. you're now ready to tackle the practice problems for that are in your syllabus for this section, and I'll post the some detailed answers for you so that you can practice through them, and then you're ready to work on your assignment for this section.